Hello, and welcome back to the Calculus 1 playlist. In today's video, we're going to be doing a brief overview on functions. So we're going to define what a function actually is, discuss domain and range, then introduce the vertical line test, and finally look at some increasing versus decreasing functions. So without further ado, let's begin. So what is a function? And let me write down a definition for you. A function is a way to transform an input into unique output. Underline transform. So the way I like to describe it to others is that a function is like a machine. So let's take this box. Let's input some values here and take an output. So the input into this little box is x, and we'll call this box f, meaning function. And the output will be f of x. So essentially, we are saying that this function transforms the input to be this new output, transforms the input of x to be a new output, f of x. So there's many different ways to denote a function. So ways to denote a function. And to start, we'll look at one that you're probably familiar with. Y is equal to x squared. So we're going to consider the square function, whereby we want to square a variable x. So in this case, y is equal to x means that our dependent variable, y, is just the x value squared. Another way to denote a function, and most commonly, is f of x is equal to x squared. So whereby we're saying that the symbol f denotes the function, and that function says we take an x value, the independent variable x, and we square it so that that gives us our output. And finally, it's the mapping rule. So we have x gets mapped to x squared, and we kind of read this as x goes to x squared. So these all denote functions. I'm going to commonly throughout this course just use this notation, f of x equals to some value or some set of variables. So an example of a function, f of x is equal to root x. And if we graph that, this is x, and this is f of x is equal to root x. Great, so that's not too bad to understand. So now in the context of domain and range, we're going to talk about domain and range. So the domain is just the set of all possible inputs to a function. So the set all possible inputs to a function. So you could say all possible x values. So these are just the allowed x values for our function to use. And the range is, well, you guessed it, the set of all possible outputs to a function. So that meaning all f of x or y values. So let's look at an example quickly. We're going to go back to x squared. So we know that x squared looks like this, and I'll write down f of x, or sorry, root x. F of x is equal to root x, and this is f of x equals to root x. This is x. So what's the domain of root x, of f of x equals to root x? Well, we know that all the possible x values must be greater than 0. That's just the property of square root. The square root is not able to take the square root of negative values. So we say that the domain is 0 to infinity. Now the range is all the possible output values. Well, we know that 0 is the minimum, and we only go upwards from there for the rest of the function. So we know that it as well goes from 0 to infinity. So that's how we go about looking at our domain and our range. So the domain is governed by what are the possible x values allowed within the function, and the range looks at what are all the possible output values to these corresponding inputs. Let's look at another example, a little bit more involved. So let's find the domain of s of t is equal to root 1 minus t squared. Great. So as I mentioned, the square root, the argument within the square root must be greater than 0 or equal to 0. So let's write that down. 1 minus t squared must be greater than or equal to 0, which is just a property of the square root. We can multiply both sides by -1, and recall from our inequality rules, when we do that, the sign must flip, so that we get t squared minus 1 must be less than or equal to 0. Simplifying, we get t minus 1, t plus 1 must be less than or equal to 0. And this looks like one of our inequality problems that we tackled in the previous videos. So how do we do this? We need to find the values of these two roots that provide a value less than or equal to 0, that hold this inequality true. So we know that if both these roots are positive or both the roots are negative, then the inequality is false because the value will be greater than 0. But if one of these values is negative and one of these values is positive, then the inequality will be true. Well, which values would we be looking for? We then look at our roots, and we know our roots are at t is equal to -1 and t is equal to 1. Therefore, we need to look at the values in between t is equal to -1 and t is equal to 1, because one will be positive, one root will be positive, and one root will be negative. So let's say I had picked 0, for example. This would be negative root, and that would be a positive root, meaning that our combination, our product, would be negative. So therefore, our interval, where t is greater than or less than or equal to 0, would be between -1 and 1. And this is our domain. Domain is -1 to 1, and I'll box that, because these are the only values of t that can be satisfying this function. So that's good. A bit of review of the inequalities, as well as touching on this new section in domain and range. Perfect. Now, how to check if a function is, I guess let's rewrite it as how to check if a graph is a function. And this is done through something called the vertical line test. So the vertical line test basically states that if a vertical line can pass through each and every point of a function and intersects with one and only one point, then it can be considered a function. Let's write that down. If a vertical line can be drawn through every point of the function and intersects with one and only one point, the graph is said to be a function. Said to be a function. So let's graph this so you can see what I mean. I'll put two graphs simultaneously. So we'll have one graph as such and one graph as such. So I'll show you what I mean. So if we can draw vertical lines through each and every point and it only intersects once, then the graph is considered a function, as shown on the left-hand side. But in this case, we have a graph whose some values intersect twice, some intersect three times. If you have a graph that intersects with a vertical line more than once, at least one time, you have a function. You do not have a function, sorry, excuse me. Not a function. It doesn't matter how many times it does this or how many vertical lines you're able to pass through. If it happens once, it is not a function. So it's a very easy test. And the last topic I want to touch on, today will be a relatively shorter video, is increasing versus decreasing functions. So let's draw two more graphs. As such. Say we got these two graphs, and it might be intuitive which functions are increasing or decreasing, but I'll give you a formal definition for them. Let's define, or let's use a different color. Let's define here as x1, here is x2. So this is f of x1, f of x2. If x2 is the next point, so following after x1, then if f of x2 is greater than f of x1, the function is said to be increasing. However, as shown on the next graph, let's get the solid line. You got f of x1, and over here f of x2. Now, if the next point, so x2, which is following after x1, if f of x2 is less than f of x1, the function is said to be decreasing. This makes sense intuitively, but this is just a formal definition for you. So to wrap up what we talked about today, we kind of defined what a function was. A function is just some sort of transformation that takes a input and maps it to a unique output. We can denote it as the way we've seen before, with y being a dependent variable, which depends on x, the independent variable. The f operator f of x is equal to x squared, or just this mapping arrow. We talked about domain and range. So domain being the set of all possible inputs to a function, and the range being the set of all possible outputs to a function. And then we touched on the vertical line test, so how to define if a graph is a function versus not a function. And lastly, we gave a formal definition for increasing versus decreasing functions. And in the next video, we'll continue our topic with functions, speaking more specifically about even versus odd functions. So if you enjoyed, like, share, subscribe, and I'll see you in the next video.